So the extension of beam reaction lecture is the internal hinges. So basically the use of internal hinges is to convert a indeterminate structure to a determinate one. Here we can see, if we consider the total beam, this would be considered as an indeterminate structure, but as we have introduced a hinge over here, so it is converting the total structure a determinate one. So the function of a hinge is to divide the entire structure into two parts at the point on which it is present. So here we can see an internal hinge at point D. So at point D, the entire beam AF will be divided into two segments. One segment will be AD and the other segment will be DF. The other name of hinge is splice. This hinge connection could be of two types. One is shear connection and another one is moment connection. So what is the use of shear connection? Shear connection connects two segments sidewise, and the moment connection connects two segments both sidewise, and it is also being connected from top and bottom portion. Here we can see the example of moment connection and shear connection. So when a shear connection is used, or a hinge of shear connection is used, it connects two beam. Like here is an example of two beam has been connected. So the main function of it is to divide the beam into two segments. So it will be divided into two segments, and then due to this shear connection, as we can see, this is a shear connection. If it would be a moment connection, then it would have been connected from top and bottom wise also. So when this is a shear connection, due to this connection, when we are dividing the beam into two segments, due to this shear connection, a vertical reaction and a horizontal reaction will arise in both segments. So as we have considered downward vertical reaction for the left segment, so we need to consider upward vertical reaction for the right segment. As we have considered rightward horizontal reaction for left segment, so we need to consider leftward horizontal reaction for the right segment. So for right segment, we are considering leftward vertical horizontal reaction and upward vertical reaction, and for the left segment, we are considering rightward horizontal reaction and downward vertical reaction. So in total, we can see that these vertical reactions are cancelling each other. That means one vertical reaction is acting downward and the other one is acting upward. These two value will remain same. The work of the hinge is to carry the reaction from one segment to the other segment. So the reaction that will arise or that will be created here at left segment, it will be carried to the right segment. Similarly, the rule is same for the horizontal reactions. The horizontal reaction that will arise in left segment will be carried to the right segment. It will be carried to the right segment, but the direction will be opposite. So in total, these two directions are cancelling it, representing that these two reactions will be cancelling each other. In total, it will remain in equilibrium, or it will remain stable. Now let's see the example over here. It's given the AF beam, and it has been connected, a shear connection has been used at point D. So we can divide the entire beam into two segments. Before that, we need to simplify our loading patterns. We can see here a uniformly distributed load, 1 kip per feet, acting throughout a length of 6 feet. So the total load will be 1 times 6, which is 6 kip. And as this is an inclined load, this inclined load will be having two components. So the slope is 3, 4, the hypotenuse will be 5. So the horizontal component will be 10 into 3 by 5, which is 6, and the vertical component will be 10 times 5 as denominator and 4 as numerator. In total it will be 8. So we had already simplified our loadings. This is this is 6 and this is 8, and now we can cancel this inclined load. So we have already simplified our loadings. Now we need to divide the it into two segments and start analyzing this beam in order to calculate the support reactions that will be occurring over here. So let's draw the free body diagram. For the free body diagram, it will be for this AD segment at point A there is a pin support. So this pin support will be having two reactions, one in vertical, one as a vertical and one is horizontal reaction. Let's denote it with AY and AX. And at point C there is a roller support, so the reaction will be CY. For E there is a roller support, so there will be one reaction which is EY. Now for this hinge, in both segments reaction will occur similarly that we had explained earlier. Let's see how to solve this problem. So we have already divide the load it into two components, divide the inclined load into two components, and then we are separating the two segment at point D. So we had separated the two segments in point D. This is our first and this is our second segment. So this is the most simplified segment. The second one is the simplified segment. As we can see, EY, which has been arised due to the roller support, EY vertical reaction, and for hinge at point D, two reaction has been represented. One is DY. As we are taking the right segment, so for right segment we used to consider vertical reaction upward and horizontal reaction leftward. So we are doing same thing here for the right segment. For this right segment, vertical reaction upward and horizontal reaction leftward, horizontal reaction leftward. And similarly this will be carried to the right segment, this will be carried to the left segment. We can see here the left segment, the same reaction will be carried to the left segment. For left segment, the vertical reaction will be downward dy, and the horizontal reaction is rightward dx, is exactly the opposite to the reactions we have considered for the right segment. So for the right segment, dy is upward, dx is leftward. For the left segment, it is opposite, which is dy downward and dx rightward. Now we can see over here that the beam has been divided already into two parts or two segments. So we need to start with the simplified segment first. So at right segment we can see three unknown reactions, which are EY, dx and dy. So applying summation of f of x equal to 0, considering rightward positive. So for this left, for this right segment, the forces acting on x direction are dx, which is acting, dx is acting leftward, so it will be negative dx. 6 is acting leftward, so it will be negative 6. From here we will get the value of dx as minus 6. So this is my dx. So dx is minus 6. As we have considered the value of dx, we have considered the sign of dx leftward, so it has come as the value, our answer was minus 6. So it is indicating that actually the reaction dx is acting towards the beam or rightward, and on that case, if we used to denote it with rightward sign, the value will be only 6. So we had written over here dx positive 6 if we're considering rightward. Now from summation of f of x, we had already got the value of dx. Now applying summation of f of y, we can create another equation, but before that it's better to apply summation of moment. So we are applying summation of moment at point D. So at point D we are taking the moment. So the loadings which will be creating moment at point D are EY and this 8 and 6 skip. This 6 skip is acting through the point D, so it will not be attending or creating any moment at point D. So 8 kip and EY will create moment with respect to point D. So let's consider EY first. EY is creating a moment in anti-clockwise direction with respect to point D. So we have considered here clockwise as positive, that's why it will be negative EY times, here the momentum is 5 feet, you can see here 5 feet, so EY times 5. Now we can see that 8 keeps acting downward and it is creating a moment in clockwise direction, so it will be positive 8, and here in this case the distance will be 5 plus 5, or the momentum is 5 plus 5, which is 10. So he had written here 8 times 10, so 8 times 10 means 80 divided by 5. From here we will get the value of EY as 16 kip. So we had got the value EY as 16 kip, which is a positive value. So this dy is acting upward and the value is 8 kip. EY is acting upward, which is 16 kip. So applying summation of f of y now, summation of f of y, we can see that this summation of f of y over here equal to 0. We are considering upward as positive. Now applying summation of f of y, we can see dy is acting upward. We have not calculated the value of dy yet, but we have already calculated the value of ey. So dy is acting upward, so positive dy. Ey is also acting upward, and we had already calculated the value of ey, which has come as 16 kip, so plus 16, and 8 kip is acting downward, so minus 8 will be equal to 0. There is no other forces in y direction for right segment, so we are applying this summation of f of y equal to 0 for right segment. So from here we will get the value of dy. The value of dy will be negative 8. So we had considered dy upward, so for that the value came as minus 8. That means actually this dy is acting downward, and the value will be on that case positive 8 if we change the sign. Now we have already calculated dy and dx and ey. So we had already calculated the value of dx as -6 keep, and it is acting leftward. So for this right segment, dx is -6. So for the left segment, dx will be acting in opposite direction, so it will be acting in this direction, and this value will be -6. And dy is -8, it is acting upward over here, -8, so it is acting upward, -8. So for the left section it will be downward, and the value will remain the same, which is -8. So this just direction was just opposite, and it will be carried to the next segment. So now we will be dealing with the next segment, which is segment AD, especially applying summation of f of x equal to 0, considering rightward positive forces that are acting on this left segment are ax is acting rightward, so positive ax. Then there is any other forces in x direction? Yes, there is dx is acting rightward, so, and the value is -6, so dx is acting rightward, it is positive, and the value of dx was -6. We had plugged the value of dx over here, which is -6. So ax minus 6 equal to 0. From here we will get the value of ax. So we had already calculated ax, dx and dy, also ey. Now applying summation of moment at a, taking moment at a, point A, with respect to point A, the forces that will be giving moment or creating moment with respect to point A are 8 kip, cy, this 6 and this -6. Not -6, -6 is the dy, dx, but this -8, which is dy, needs to be considered for this moment at point A. Now applying moment at point A, starting from the initial point, ax and ay will not be giving any moment, as we have considered with respect to point A. 8 kip is acting downward, so it will be creating a moment in clockwise direction. So we have considered clockwise as positive over here, so +8, and the momentum is 4. As the distance is 4 feet. Then cy is acting upward, it will be creating a moment in anti-clockwise direction, so it will be -6 -cy, we have taken -cy, and the distance is 4 plus 4, which is 8. Now 6 kip is acting downward, it will be creating a moment in clockwise direction, and the momentum is 4 plus 4 plus half of 6, which is 3 feet. So 4 plus 4 plus 3 is 11, so +6 into 11, and then 8 is -8. This -8 is giving a moment in clockwise direction, so it will be -8 times 14. So this minus sign was not for the clockwise direction, this is for the value, as the value is -8, so we are plugging here -8 times 14, as the total distance is 4 plus 4 plus 6, which is 14. From here we'll get the value of cy as -1.75. Now applying summation of f of x equal to f of y equal to 0, we can see ay is acting upward, 8 kip is acting downward, so -8, skip is acting downward, so minus 6. This cy where we have calculated the value of cy as minus 1.75. so cy, we have considered the value of cy, direction of cy upward, so plus cy, and lastly dy we had considered downward, so minus dy. So plugging the value of dy, which was minus 8, so minus into minus, it will be positive, so it will be positive 8, and the value of cy was, we had now calculated, which was minus 1.75. Plugging the value of cy over here, we will get the value of ay as 7.75. In this way, we need to calculate the reaction of the supports.